Tonight is Wednesday, January the 23rd, 2013, and I want to document a very nice operating Fender Hot Rod DeVille that came into my shop today. Just doing an exceptional job. What it had was a bad socket. I've already got it taped up down here. I will try to give the client back their bad parts. It was this second socket right here. I don't want to stick my finger in because it's on, but you could wiggle a tube and it would do some really terrible things. I've seen that a few times, not too many. But anyway, the purpose of tonight is actually just to document how well this thing is actually performing and some of its parameters. I have not changed anything. I've made measurements, and here's what I got. Okay, if I plug my input right there, you might be able to hear it. The output right here is running up to one of these 8 ohm precision, these 1% low inductance load resistors. We're going to be watching it mostly just right here on an oscilloscope. We can see it's clipping pretty heavy because I'm driving really hard. Right here is its total harmonic distortion. It's THD 9.8%, and here's its output voltage across 8 ohms. And there's its frequency right there, 1 kilohertz. Okay, this is a spectral analysis, or spectral display. Not analyzing it, but we're not going to worry too much about that. It doesn't have very many harmonics there. Let's see, we're in linear mode. Let's go to log. Nah, we'll have to play with this thing, and I don't want to do that. Anyway, the point here that what I'm really, I guess what caught my attention tonight is how well it's performing. These tubes here are Svetlana's 6L6s, and I think they're just doing an exceptionally good job. And here's our output, 10% at 22 point, we can run it up to about, we call it 23 volts. It would average up 10% at 23 volts. And if we do the math there, we get 23 squared at 8 divide 66 watts. Really doing great. I've seen a lot of these Hot Rod DeVilles, and they all do quite well, but this one's doing exceptionally well. And what I'm actually documenting here is just what's in it, because the only thing I've done is change that tube socket. Okay, now let's remove the drive and let it settle down for just a minute, and we'll look at the plate voltage, the bias voltage, and the static plate dissipation. Okay, in these amplifiers, there's a test point right here. I don't know how well that'll show up, but it says bias test point. I hope you can kind of see that. I can get enough light and get it to focus really good. Bias test point. It's right there. That's it. Okay, now it's across a 1 ohm resistor. What it is the two cathodes of these 6L6s are tied parallel, and they go to ground through this 1 ohm resistor. So if you put your voltmeter right here and you look down here, this is in millivolts, 115 millivolts. Since it's across a 1 ohm resistor, it would translate to 115 milliamps. So half of that, which would be half of 115, half of 115. Let's do it here. Let's do it by the book. 115, 2 divide. So it's 57.5 milliamps, thereabouts. Now let's check the plate voltage. The plate voltage is right here on pin 3. 456 volts. Okay, you multiply this, that'd be 0.0 enter. Oh darn. Okay, sorry. 115 milliamps would be, half of that would be 57.5 milliamps. That's 0.0575, 57.5 milliamps, enter, and times the plate voltage, once again, so we don't make any mistakes. 456 times. There is its static plate dissipation, 26.2 watts. Okay, at 26.2 watts, if you look right here, the plate dissipation, the maximum plate dissipation of a 6L6 GC is 30 watts. And 26.22, enter, 30, divide, that's about 87% of its maximum plate dissipation. So I think the reason I'm documenting this is because it's performing so darn well. It really is. I'm really pleased with it. Somebody put some Gliptol or something right there and you know, tried to seal that one down. Looks like something I would do, but I didn't do that. I don't think I've ever worked on this amplifier. Really performing very well. And that is what's in it. That's Fitzlana's. And these over here, I think these are groove tubes, if I'm not sure. The 12AX7s. Just doing a great job. So, I know there's been a lot of discussion about what type of static plate dissipation an amplifier should be run at. I think this one's run kind of high, but actually running it kind of high actually makes it perform better. That's the way it works. Shortens the life of the tubes a little bit, but you know, you gotta pay for performance sometimes. Anyway, this thing's just doing great, and that is what it is. Okay, let's see. Somebody's going to ask, what is the bias voltage? Let's look at it. 3, 4, 5. That would be right here. Pin 5. It's minus 48. So the bias voltage is minus 48. The plate voltage is 455.56. The input voltage is right there. It's an analog one, but that's about 118.5. So we call it 120. And again, the voltage across the 1 ohm resistor is 115 or so milliamps, which translates to 115 millivolts being across a 1 ohm resistor. There you go. So am I suggesting you run your amplifier this way? Not really. I'm just documenting what I see and what I get and how it performs, and you can make your own choices. Hope this helps.